This is Chapter 15 of Learning Web Design, which introduces floating and positioning techniques for page layout. In order to understand floating and positioning, it's important to understand what happens without them. In the normal flow of an HTML document, elements are rendered top-down and side-to-side. Block elements fill all horizontal space within their containing elements, causing them to stack in rows. Inline elements flow like text within paragraphs, one after the other until they reach the end of a line. When the browser window is resized, the elements are adjusted as required to comply with the normal flow rules. Floating and positioning are techniques for breaking the normal flow rules in some very specific ways. Blocks sometimes need to be displayed side by side instead of stacked top to bottom. Elements sometimes need to be displayed in a different order than they appear in the HTML source. Inline text sometimes needs to wrap around elements besides images. Finally, sometimes we want an element to appear at a very precise location in the document, regardless of where it appears in the HTML source. Floating and positioning are provided to handle just these sorts of situations. While they are often lumped together as two ways of achieving the same effect, they are actually very different approaches. Floating is the more commonly used of the techniques, in large part because it is flexible enough to handle lots of situations without much risk of causing a layout disaster. Floating is an element moves it to either the left or the right, towards the edge of its containing element. Other elements are then allowed to wrap around the floated element, filling up available space. To keep the floated element from getting crowded by the content flowing around it, all floated elements are treated like blocks, with padding and margin on all four sides. Common uses for floating are to create multi-column layouts, horizontal navigation menus, and tabular layouts without resorting to HTML tables. To float an element, just set its float property to either left or right. Note that there is no way to float to the center, only left or right. Here we see an element floated left, allowing the text to flow around it to the right, with padding and margin used to provide some white space. Floating an element has two very useful effects. First, it allows us to cause an element to display earlier or later than it appears in the HTML source. The effect has its limits, however, as it can never cause an element to float upward, only left or right on the page. The second effect is that it allows other content to flow upward around the floated element, though never above the top of the floated element. Here we see an example in LiveWeave. There are two floated elements, with the first element appearing before the second in the HTML source. However, because the first element is floated right and the second element is floated left, the second element is rendered before the first element on the page. Also, the text that follows both elements flows between them, filling up the available space. As we just saw, we can float multiple elements at the same time. Each floated element floats to the indicated side as far as possible without overlapping with other elements. One way to think of it is that a floated element is like a boat that is pinned against a dam wall with other elements flowing like water over the center of the dam. Here's an example from the book. If several elements in a row are floated left, then they appear one after another on the same line until the horizontal space is used up. The next left floated element then appears on the next line flush with the left side. The remaining unfloated content fills the gaps at the first opportunity under normal flow rules. The floating rules are more or less the same for block elements and inline elements. However, to be consistent with the book, we'll cover them here separately. A block float will shrink to minimize its horizontal white space to make room for other elements to flow around them. Take care to specify the width of a floated element, however. The problem is that CSS3 does not dictate how to calculate the width of an unsized floated element. Most browsers will use the minimum width possible without causing content to spill out. Other browsers may elect to expand the width as much as possible. To be sure, set the size yourself instead of relying on the browser to do it for you. The other thing to keep in mind is that a floated element will never appear any higher up the page than it would under normal flow rules. Again, it is not possible to float upward, only left or right. Floated inline elements behave like floated block elements. All of the usual things we expect to work for block elements like settable box heights, vertical margins, borders, and padding also work for inline floats. Further, since floated elements are not in the normal flow, their margins are treated as independent of anything else, disabling the margin collapse effect that trips up so many new web designers. Oh, and the bit about margin collapse works for block floats as well. Here we see an inline element being floated to the right. It looks exactly like a floated block, with margins, padding, and border. If there were two of them, then we'd see no margin collapse between them. Well, the ability of floats to suspend normal flow rules is pretty handy. We often want to restore normal flow rules for the content below the floats. To resume normal flow, a rule can set the clear property. The property allows us to restore normal flow rules on the right side, left side, or both sides. A common use case for clearing floats is for the footer of a page, which we'd prefer not to flow upward into the main content. Here we see paragraph text clearing the floats of the floated blocks above it. The result is that the paragraph will treat the floats like normal blocks and start on a new line below them instead of flowing between them. Floating can sometimes cause unintended quirks in the way a page is rendered. If a child element is floated, but its parent is not, then the parent no longer has to allocate any space for the floated child. The height of the parent element will then shrink to fit the rest of its contents, even if that means the floated child hangs over the edge of the parent's box. We'll see what that looks like in a minute. There are two workarounds, each of which works about as well as the other. We can float the parent too, causing it to be on the same plane as the floated child and thus have to allocate space for it. Or we can set the parent's overflow property to auto, forcing it to account for the overflowing floated child. The example from the book illustrates the problem, with the floated image on the left spilling over the edge of the parent element, which is outlined here in green. This is a more extreme example, where the parent's element's height shrinks to 0 because all of its children are floated, leaving it with nothing to fill the vertical space. It ends up as just a dotted line. This figure illustrates both workarounds. The one on top is the float the container technique. The one below is the overflow technique. Again, both work about the same in practice. Floating is commonly used to flow contents in columns. Each column is a container for its contents. The columns are each floated to the left so that they appear side by side in left to right order. The page footer then clears the floats above it so it can span the full width of the page rather than flowing upward. We'll cover this again in Chapter 16. The second method for taking content out of the normal flow is positioning. In many respects, positioning is more powerful than floating, allowing content to display just about anywhere on the page, regardless of where it is in the source. However, one needs to take care with positioning. Each positioned element makes the page a little more brittle, with hard edges that can break when the page is resized or when files are returned out of order from the web server. We say that overuse of positioning is a symptom of pixelitis, a potentially dangerous condition for any serious web designer that can ultimately lead to burnout and maybe insanity if you do it long enough. Positioning is specified with the position property, which states what kind of positioning is being used. In addition, there are 4 offset properties that indicate a reference location on the page. The example given here is using absolute positioning to place the element at the top right corner of the page, even if that overlaps with other content. Like with floating, the positioned element then uses the full box model, just like a block. There are 4 kinds of positioning that can be specified. The default is static, which is what unpositioned elements get anyway. Relative positioning acts like negative margin, shifting the element from its normal place in the normal flow. Absolute positioning places the element exactly where specified on the page. Fixed positioning places the element in a fixed location within the browser window, not moving at all as the user scrolls the page. The location of a positioned element within its container is specified by the offset properties top, right, bottom, and left. Each offset controls the gap between the element and the given edge of its containing block. How this works in practice depends on the type of positioning being applied. With relative positioning, the element is shifted as specified by the offsets. Curiously, the offsets work in the opposite direction from what's specified. In this example, from the book, the top offset causes the element to shift downward 30 pixels, while the left offset causes it to shift right by 60 pixels. Any space it would have taken up before the shift remains as empty white space. If no offsets are given for a relatively positioned element, then it remains where it would normally, though with some special characteristics that we'll cover in a little bit. Absolute positioning removes the element entirely from the normal flow, leaving no white space behind and allowing other elements to fill up the space. To avoid overlap, the other elements around it have to carve out white space with their margins. The offsets indicate the gap between the edge of the element and the corresponding edges of the containing block. Usually the offsets refer to the edges of the page, allowing the element to be anywhere on the page, even if it causes an overlap. In most situations, only 1 or possibly 2 offsets are given. There are special rules that come into play when conflicting offsets, like both left and right, are specified. In this example, the top offset specifies a 30 pixel gap between the top of the element and the top edge of the page. The left offset then specifies a 60 pixel gap between the left edge of the page and the element. Usually, absolute positioning offsets refer to the whole page, but what if we want to place the element within another element? For example, we might want a logo to appear at a specified location within the page masthead. That way, if we shift or resize the masthead, the logo will stay put without overlapping the edges. To handle a case like this, we would take advantage of the positioned ancestor rule, which states that any positioned element is always placed relative to its nearest ancestor that is also positioned. So for our logo masthead example, we would position the masthead, the parent, so that the logo, the child, stays where it's told. So, to be more direct, to absolutely position an element within its parent element, apply positioning to the parent. The parent is now called a containing block. This solves most of the overlap problems, except of course for possible overlap with other elements inside the containing block, or perhaps if the offsets push the element over the edge of its containing block. We'll look at that in a minute. This example from the book shows a purple box positioned within a paragraph block. To make the positioning relative to the paragraph instead of the page, the paragraph, which acts as a parent here, is relatively positioned with no offsets. This has no effect on the location of the paragraph, but it does affect the position of the purple box inside it. If the offsets are too big for the containing block, then it's possible to push the positioned element over the edge of the containing block and into surrounding content. How can we prevent this sort of thing? By floating the containing block itself, which will cause it to stretch to contain the positioned element. This situation is not very common, so you may not ever come across it unless you do a lot of work with complex responsive layouts, particularly ones with mobile targets. The last kind of positioning is fixed, where the element is placed in a specific position within the browser window. Basically, it always uses the window's viewport as the containing block, regardless of how the other elements of the page are styled, but otherwise works like an absolutely positioned element. This technique is commonly used to keep the masthead of the page always visible as the user scrolls down the page. This can cause some problems if the masthead itself is too big to fit within the viewport, as can happen with mobile devices. To permit overlap, positioned elements reside in a layer above the normal flow. Actually, there are practically an infinite number of possible layers like that, each with a unique z-index value. To cause an element to move up in the stack, just raise its z-index. To hide an element beneath other elements, just lower its z-index. This is how lots of JavaScript-based interactive effects work. It's also used to keep fixed mastheads, Facebook-like icons, and being obscured, etc., from being obscured by page content. This brings us to the end of Chapter 15, which introduced a lot of new concepts. In many respects, this chapter marks a transition in the book, away from selectors and properties to more advanced topics. From here on out, the CSS chapters are more about how to apply what we've already learned than about introducing new CSS terminology. Thank you for following along with Chapter 15 of Learning Web Design. See you later!